In this video, I'm going to be going over mesh analysis, which, like nodal analysis, is just another standardized circuit solving technique. And while nodal analysis was basically just the application of Kirchhoff's current law in conjunction with Ohm's law, mesh analysis is instead based upon Kirchhoff's voltage law, again with the usage of Ohm's law. So since it's a standardized technique, there are just a few steps you can follow. So first, step one is to assign mesh currents to each mesh. So what is a mesh? It's basically any loop within a circuit that doesn't contain any other loops. So for example, in this circuit, this is a mesh, and this is a mesh, because both of them do not contain any loops within themselves. However, this is a loop, but it is not a mesh. Now, something important to note is KVL, Kirchhoff's voltage law, it applies to both loops and meshes, but with mesh analysis specifically, we're mostly just going to be talking about these meshes themselves. Okay, now what is a mesh current? Okay, so let's say we have this circuit right here. And let's say you have a current right here called IA, and then a current right here, IB, and a current right here, IC. Now, when we draw our mesh currents, we pick a direction inside a mesh, and we make a mesh current either clockwise or counterclockwise. I always just draw them clockwise, exactly like in this example right here. So let's say we've got an I1 and an I2 mesh current. Now, when we go on the outside of this loop, following this path right here, we can see that I1 is equal to IA. They are in fact the same. However, when we are right here on the middle of the path, IB is not equal to I1. Even though I1 is going following down next to IB, you have to look over here. There's this I1 going down and there's this I2 going up. So here you could define IB in terms of the other two by just saying, okay, IB is equal to an I1 going in the same direction minus an I2 going in the opposite direction. So what does a mesh current really even mean? It's not actually a real current. It's just an invention for the ease of solving circuits. It makes solving circuits easier to have a mesh current, but it doesn't really mean anything physically. However, you can define it mathematically as so. So now moving on, step two is to apply KVL, Kirchhoff's voltage law, to each mesh using Ohm's law, V equals IR. And then step three, the final step, is to simply solve for the mesh currents. So let's go ahead and solve this following these steps. So step one is to assign mesh currents to each mesh. It's already done for us. Step two, apply KVL. So we're going to start out with mesh one and then just do a KVL. So I'm going to look at it starting at this 4 ohm resistor and going that way. So we're summing the voltages, and the sum of the voltages in the mesh has to be equal to 0. So we're going to use V equals IR for I1. We're passing through the negative polarity, minus 45 volts plus 2 I1. And then we get to this 12 ohm resistor. Now, the thing we have to think about is this I1 right here and this I2 both pass through this 12 ohm resistor. So we have to account for both of those. So the way you deal with that is whichever mesh you're doing, like right now, we're doing the I1. So there's an I1 going that way. So you just say plus the resistance times whichever loop you're on. You're on the I1 loop, so you do that I1 minus whichever the other one is, I2. Because from the perspective of the first mesh, there's an I1 going that way and an I2 going that way. So the total current at that resistor from the perspective of the I1 mesh is just I1 minus I2. So V equals IR, V equals 12 times I1 minus I2. And that all equals 0. Then we can just simplify this equation. So that's going to be our equation for the I1 mesh. Now we're just going to do the I2 mesh. So this time I'm just going to start up on top and go that way. So we're going to have first a 9I2 plus 30 this time because we're passing through the positive pole, plus 3I2 plus, again, this 12 times. This case, we're passing through with respect to the I2 loop. So we're just going to say I2 minus I1 all still equal to 0. Then you can just simplify this equation. And this will be the equation for I2. All right, now we can just follow step 3, solve for the mesh currents. As you can see, we have 2 equations and 2 unknowns. So you can just solve this system and you should end up with I1 equals 2.5 amps and I2 equals 0 amps. Okay, now let's move on to another example. This time we are looking for the current I naught, which is going to be this current right here. Now, the only thing you have to know that's different from the previous problem is we're not looking for a mesh current. We are looking for the current that travels all throughout this wire. And the only thing you need to know is that the current on the outer edge of a mesh is equal to the mesh current itself. So all that means here in this case is that this I naught is on the outer edge of this mesh with I3. Therefore, we can say I naught equals I3. Okay, and now we just solve the problem exactly like the previous one. So we start with our KVL and do it for each mesh. So for mesh 1, we have minus 16 plus 4 times. Now our I1 is going that way. So we've got I1 minus I3 plus 2. And then our I1 is still going that way. So 2 times I1 minus I2, all equal to 0. And then we can just simplify that equation. And then just combine all our like terms. And then the final equation will be 6I1 minus 2I2 minus 4I3 equals 16. Okay, we can repeat the process for mesh 2. So we'll have a minus 10 I naught plus 2 I2 minus I1 plus 8 I2 minus I3 equals 0. And then simplify. Then remember, I naught is equal to I3. So you can just change this I naught right here to an I3 and then combine like terms. And you should get the following equation. Now, one more time for I, we'll have a 6 I3 plus 8 I3 minus I2 plus 4 times I3 minus I1 equals 0. Simplify and combine like terms. All right, now that we have 3 equations and 3 unknowns, we can go ahead and solve the system. So when you solve the system, you should end up with I3 being equal to negative 4 amps. However, we already know that I naught is equal to I3. Therefore, we can just say I naught equals negative 4 amps. And that is our answer.